Hi, my name is Lavneswar and my metric number is 33DPE 19123. Today I am going to present about air coolers and condensers. Let us see about the basic principle of heat transfer. Heat transfer. We are going to see about working principle. The working principle is a heat exchanger is a device that allows heat from a fluid, a liquid or a gas to pass to a second fluid, another liquid or gas, without the two fluids having to mix together or come into direct contact. Here we can see the picture hotter before, then became the cooler after, and the cooler before became hotter after. They didn't mix. Okay. Next, we are going to see about logarithmic mean temperature difference. The logarithmic mean temperature difference (LMTD) is used to determine the temperature driving force for heat transfer in flow systems, most notably in heat exchangers. The LMTD is a logarithmic average of the temperature difference between the hot and cold feeds at each end of the double pipe exchangers. Let us see about air coolers and condensers. Short form is ACC. Air coolers and condensers. Let us see some pictures about ACC. This is a picture of air cooler and condensers. Nextly, the working principle of air coolers and condensers. Let us see a video about working principle of air coolers and condensers. Okay, the boiler. Uh, okay, the boiler out the steam from the superheater to turbine. The generator changed to air cooler condenser, and at the air cooler condenser uh, the steam changed to water. The water hot pass hot well and condensate pump, and then condensate polishing system, and go through the low pressure heater and go through the de-reactor and feed water pump. Then the water have high pressure heater and again go back to boiler. This system will happen continually. Okay. Next, uh, next we are going to see about the construction of air coolers and condensers. The air cooler and condenser is designed to transfer heat from a working fluid to a secondary fluid or the surrounding air. The condensers release on the efficient heat transfer that occurs during phase changes, in this case during the condensation of vapor into a liquid. The vapor typically enters the condenser at a temperature above that of the secondary fluid. As the vapor cools, it reaches the saturation temperature, condenses in and condenses into liquid and release large quantities of latent heat. As this process occurs along the condensers, the quantity of vapor decreases and the quantity of liquid increases. At the outlet of the condensers, only liquid remains. Some condensers design contain a additional length to subcool this condensed liquid below the saturation temperature. Let us see about the components used in air coolers and condensers. The components used in the ACC is tube bundles, manifold heater bringing steam into tube bundles, fans delivering cooling air including fan stacks, teething, steel structure for fixing the components mentioned above, steel walkway and ladders, collecting chambers of cooled medium. Let us see about the advantage of air coolers and condensers. The advantage of using this design include not having to do water piping, not necessary to have water disposal system, saving in water costs, and not much scaling problems caused by the mineral content of water. It also easier to install and has lower initial cost. This there isn't much maintenance problems. Let us see about the disadvantage of ACC. The disadvantage are that it requires higher power per ton of refrigeration, has shorter compressor life, and on days when most cooling is required, the least is available. Okay, okay. This is the reference to do the presentation. Thank you.